The population is just going to keep on getting bigger. And natural resources are just going to keep on getting smaller. All the while, technology will get faster and cheaper, finagling its way into every aspect of our life, all over the world. I am interested in what that future looks like when it is harder to access water than it is to access information. Is the convenience of infinite knowledge worth it when in 2050, 57% of the world lives with water scarcity? And the rest of us have to scrap for the little that's left? Should we be concerned when most people are getting Wikipedia before they get water? This is a project that discusses that hypothetical future. I want to project our everyday information usage onto the future of water usage to both highlight detrimental dependencies and provide an alternative economy for the future of consumption. As we all know, we have been twisted into information addicts, and this dependency is fundamentally changing human behavior. When demand for water skyrockets, I see no reason why companies won't use its limited access to manipulate us for their gain. With a corporation's algorithmic fingers on the faucet, we will see selective distribution of water, where only those who can pay a premium receive the cleanest water. Similar to Amazon's selective user pricing or Google's targeted advertising. Perennial is a network of home water reclamation devices that ensure communities take control of their water before it is used to take control of them. This is a model of a unit that lives in the bathroom, and it uses forward osmosis to turn wastewater into perfectly potable water. The water is then redirected back into the house or to another home in its network. Other homes have similar units that collect gray water or humidity from the air. Linked by an algorithm trained on gift economies as opposed to market economies, water is gifted back and forth in a closed system to each family exactly when it is needed. I was inspired by the agricultural technique of permaculture and how plants in that system share resources. Microbes on the roots of nitrogen-fixing trees absorb nitrogen from the air and then litter in the form of bean pods are dropped from trees enriching the soil around it, fertilizing plants nearby. I like how organisms in this model use waste for the benefit of its neighbors. This, combined with water circulation methods used on the International Space Station, was the basis of my project. The ISS has to recycle water because it is too expensive to fly fresh water up. So it makes for a good case study for life on Earth with water scarcity. This system was designed with dense middle-class communities in mind, valuing relationships, resources, and responsibility by sharing water in a gift economy is both environmentally and socially sustainable by creating surplus rather than debt or shortage, a necessary bolster for the growing middle class.